Yeah, good evening students. Today I am going to take a session on production technology. The topic is machines. So here, to produce any component, the machines are the prior stage. The selection of the machines are the prior stage, the first stage. So these machines are, what is a machine? Machine is a device which converts the raw materials into finished goods, raw materials into finished goods. So as per the requirement of the component shape, we need to select the type of machine. So we have the different types of the machines are there. We will see. Number one is the lathe machine. Lathe machine. Number two is drilling machine. Number three is shaper machine. Shaper machine. Number four is slaughter machine. Slaughter machine. Number five is milling machine. Milling machine. Number six is grinding machine or planar machine. Planar machine. Number seven is grinding machine. Grinding machine. We will see lathe machine, drilling machine, shaper machine, slaughter machine, milling machine, planar machine and grinding machine. As surface finish, whatever the surface finish that you want, that means any product is a finalization, the final operation is the grinding operation. Whether the component is come across lathe work, drilling work, milling work, shaper work, slaughter work or whatever the kind of the machines are there, the finalization of the product is with the super finish. So that super finish is going to be operated in the final operation, that is nothing but the grinding operation. So today my session is on lathe machine. What is lathe machine? What are the different types of lathe machine? What are the tools which are used on lathe machine? What are the operations are carried out on the lathe machine? These are the topics I am going to discuss in this class. See here, lathe machine. Number one is the lathe machine. Lathe machine. What is a lathe machine? Here in the lathe machine, the tool is stationary and work component, that is the workpiece is under the motion. The workpiece under the motion. Okay. Whereas in drilling machine, the tool is under motion and workpiece under stationary. These two are two different. In lathe machine, the tool is constant. Tool is constant. That means tool is, we can operate, we can change its position. So left side to right side to left side, forward motion, backward motion, upper direction, lower direction or somewhat the inclination, somewhat some conditions. But in the lathe machine, the workpiece is under motion. What kind of motion? Is a cylindrical motion. The workpiece is always rotates in a holding device. That holding device here it is called as the chuck. CHUCK, chuck. Okay. So there are different types of the chucks are there. The chuck comes under the holding device. That means, so when the workpiece is firmly fixed in the holding device, then only the cutting is possible. Here the cutting is nothing but the removal of unwanted material from the workpiece. So that is the process is going on the lathe machine. Okay. So first of all, we go for to discuss about what are the important parts are there on the lathe machine. Number 1, parts of the lathe machine. What are the parts are there? Parts. Number 1 is headstock. Headstock. I will explain later individually. Number 2 is tailstock. Tailstock. Number 3 is carriage. Carriage. Number 4 is tool post. Tool post. Number 5 is bed. Number 5 is bed. Number 6 is tray. Number 7 is base. So these are the important parts which are observed on the lathe machine. I am going to explain each and every part. What is headstock? Headstock is operating by means of a motor. That means here, as I told earlier, where we are going to fix the workpiece, that means in the headstock. That means always the workpiece is under motion, clockwise direction or anti-clockwise direction. As per our requirement, we need to operate it clockwise direction or the anti-clockwise direction. Always the workpiece is rotates against the tool. So against the tool in the sense, if the workpiece is rotates this direction, the tool is operate in opposite direction, then only the removal rate is expecting from the motion. So whenever the tool is interacting onto the surface of the workpiece, already we mark the dimension how much the removal rate is required. That is called as the material removal rate. Material removal rate. Material removal rate. MRR. Material removal rate. Okay. So it is already calculated earlier before we want to go for the number of operations or the type of operation are going to be operate on the lathe machine. So material removal rate. Here the material removal rate is depends upon the way that operation is selected. There are different operations are there which are going to be operate on the lathe machine. Headstock, tailstock, carriage, tool post, bed, tray and base. These are the important parts which are observed on the lathe machine. I will explain with the schematic diagram later. Sketch. So headstock. Headstock is always observed at the left side of any kind of the lathe machine. It is fixed at the left side. That means if operator stands just like my position, the left side is always observed as the left side is always observed as the headstock position. Right side is the tailstock. Where the body is there, where the operator body is there, it is coincide to where the carriage is observed on the lathe machine guideways. Lathe machine guideways, that is nothing but on the bed. So headstock is, it is a live center. Headstock is also called as the live center. Live center. So live center means always it is observed as in motion. What kind of motion? Circular motion. Circular motion. Circular motion. Next, coming to the tailstock. Tailstock is called as the dead center. Dead center. Dead center. Dead center means it is observed always at the right side. It is not in motion. The tailstock is, the purpose of the tailstock is to support the workpiece whenever the length is more than the expectation. That means whenever the length of the bar is very high, so it has to support at one end. First end is fixed in the headstock. The other end is required to support it, because unless otherwise there is no support from the right side or the tailstock, the deviations which are expecting from its center, that means it is called as the unbalancing. To get the balance of that particular workpiece, we need to support from right side end. So there we are going to observe the tailstock. The tailstock is also called as the dead center. Headstock is called as the live center. Next one, carriage. So the carriage is sliding over the guide vanes of the bed of a particular lathe machine. That means on the bed there are guide ways are there. So these guide ways are observed as a robust construction because it has to bear the live center, headstock, tailstock and carriage. So it has to be designed with a robust construction. That means which has to bear the maximum load. So there are three important parts which are fixed on the guide vanes, that is nothing but the bed. Left side is observed as the headstock, right side is observed as the tailstock, at the middle we need to observe the carriage. So the name itself, carriage. So carriage means it has to carry some of the parts which are going to be operate onto the workpiece. So what are the parts here? So here the carriage is carrying the tool post. It has to carry the tool post. So the tool post is firmly fixed because there is no deviations which may not expecting during the operation. If deviations are there, that means for example, if the tool is not fixed firmly, what happens? The deviations are expecting, that means it may not penetrates onto the workpiece firmly. So before we want to operate the tool, it has to be checked firmly whether it is fixed strongly or not, firmly fixed or not. Then only we can operate the machine itself. Okay, so that is about the carriage. Next, tool post. So there are 4 tools or the 6 tools which are going to be fixed on the tool post. So for example, if the tool post is designed with a hexagonal shape, so hexagonal shape means there are 6 faces are there. So each and every face we can fix the 6 tools. Ordinary lathe machine, it is going to be accommodated the 4 tools. Okay, so X direction, Y direction, Z direction, opposite direction. There are 4 tools simultaneously we can fix on the tool post. Okay, so as per our convenient, it is to be observed only the single tool has to be fixed, because if it is the multi tool, so it is an inconvenient to operate the operator. So that's what. So after one operation, you want to change the tool for the remaining operation or the forthcoming operation. So that is about the tool post. Next one is the bed. So bed in the sense, it is the near part, that means where the guide vanes are observed on the bed. So all the headstock, tailstock and carriage is going to be fixed on that one, right? So nearby that one, nearby the tray, in between the bed and the tray, so there is one more important part is there, that is called as the spindle. Okay, so that is the next operation for that one. Next, base. So base means it has to be fixed on the surface. So usually the lathe machine, all the lathe machines, for example, if the group of the lathe machines are observed in a factory or in a manufacturing system, all the lathe machines are fixed with a 72 degrees inclination. 72 degrees inclination. Why it is to be fixed with a 72 degrees inclination? In the sense, for the convenient movement of the operator. That means, for example, if all the lathe machines are fixed straight away, so the movement of the operator is very difficult. So because it has to move, the operator have to move to back side or the left side or the right side or in front of the lathe machine. It is inconvenient for the movement of whenever all the lathe machines are fixed in a row. That means it is parallel wise. So it is very difficult. So that all the lathe machines are fixed somewhat the inclination, that the inclination is 72 degrees inclination. Okay. So this is the important parts which are observed on the lathe machine. Now see the one line diagram of the lathe machine. See here. This is the line diagram of the lathe machine. Yeah. Headstock, tailstock, bed, this is the base, and here the lead screw is observed here. It is to be fixed here, the lead screw. The purpose I will tell you later. What is the purpose of the lead screw? This is only the line diagram of the lathe machine, and here it is observed as the carriage. This is the carriage. Check. Directly it is a hole or a spindle which is going to be observed here, and here the tool post is there. This is the tool post. Base is fixed on the floor by means of the bolts and the nuts firmly. It is operated by means of the belt drive. Okay. So there we are going to fix the motor here. This is the motor. It is operated by means of the belt drive. A pulley is there. So this is the belt drive motor. These are the line diagram. What I represent there, it is the line diagram of a lathe machine. See the parts here. This is headstock. Headstock. Tailstock. So it is also having the movement on the guide vanes of the bed. It is moving left to right or the right to left, but it is fixed. This is the fixed part. It can't change its position. It will be fixed. The headstock is fixed, but there is a live center is there because the check is connecting by means of the pulley. So the pulley is connected to the motor by means of the belt, so that whatever the motion, that means the motor is converts the electrical energy into mechanical energy. So here the mechanical energy is nothing but the motion, revolution, displacement. All these are the mechanical motions. So headstock. This is the check. This one is the check. Here is the carriage. This is the carriage. Tool post. Tool post. Lead screw. Lead screw. This is the base. Bed. Motor. This is the belt drive. These are the important parts of the lathe machine. So what is the purpose of the lathe machine? The purpose of the lathe machine is to remove the unwanted material from the circular cross sectional objects. Circular cross sectional objects in the sense it is a circular shaft. Okay. So here where we see the circular components in the sense, so take a rod, a circular cross section rod. So it is going to be designed with stepped diameter. Are the conical shapes or external threading purpose. So all these are the operations which are carried out on the lathe machine. So here the workpiece is going to be fixed at here. In the check, there are two types of checks are there: 4-jaw check and 3-jaw check. 4-jaw check and 3-jaw check. Number 1 is 4-jaw check. Number 2 is 3-jaw check. So here the jaw means, so for example, see, if it is the 4-jaw check, 1, 2, 3, 4. So a screw is going to be relieve its position. Relieve in the sense closing and opening. A single rivet or the screw which is going to be rotated by means of a drive. Okay. So with the help of the key, so we can operate the position of the jaws, either closing or the opening. So see here, it is opening and this is the closing. For example, if it is the case of the workpiece, so feel that one, this is the workpiece. So here the workpiece is going to be fixed between the 4 jaws. So we are going to operate by using of the key, Allen key. So we can rotate clockwise direction, anti-clockwise direction. The jaws are opening and closing. How much of the tightness that you want, you can operate the Allen key. So to tighten the jaws, that means all the jaws are operating just like this one, opening and as well as the closing. So there are 2 types of jaws checks are there, 4 jaw check and as well as the 3 jaw check. So here the accuracy of the operation is depends upon how we are going to fix the workpiece in the check. Okay, so that means, so before we go for to operate the workpiece, whatever the operation that you want, so before you go for to operate it, first of all check its center in the sense the axis of the headstock and axis of the tailstock should coincide. And so the fixing of the tool is also very important here. That means always the tool is locates or adjustment of the tool at its center of the workpiece itself. So for example, if the cross section, always the cross section of the job is like this one. So this is the center. The tool is going to be set at like this one. This is the way of the setting. Then it is possible to remove the uniform unwanted material from the surface of the workpiece. This is only the possibility. So before we go for to operate whatever the operation that you want onto the workpiece, so all these are the steps which are necessary. The setting of the tool, setting of the workpiece, these 2 are must and should accurately coordinate. Then only it is possible to remove the unwanted material from the workpiece. That is uniformly. We can remove the material. So that is not a problem here. But the case is the uniformity of its circumference. That is important here. Okay. And so as per the type of the material, we can select the speed. So for example, if the material is very strong, so the tool is going to be cut. The tool is going to be interact onto the material. So whenever the strongest metal is there, so for example mild steel, here the workpiece is the mild steel, the speed will be very high is required. Okay. If it is a case of the aluminum, so it is a soft metal. So soft metal means it has to rotate with the lowest speed and the tool is going to be interact onto the surface of the workpiece. So because it is a soft material, the workpiece has to have rotate the lowest speed. So because if it may be observed as the highest speed, the interaction of the tool and the surface of the workpiece, so it has to be getting high temperature interacting. That means whenever the tool is interacting onto the surface of the workpiece, much more temperature is observed on the surface of the workpiece. If it is a case of the soft metal. If it is a hard metal, so there is no such kind of the problems. That means, so if it is such examples are maybe came to know, so we can operate with the cooling. That means, so the cooling supply, lubrication process is also very much important in the lathe machine, drilling machine, for all the machines here. Okay. So here the lubricating oils or the lubricating minerals or here we can use sometimes the water is also the lubricating purpose. That means water is also one of the example of the liquid which are going to be carry the temperature, so where the tool is interacting onto the surface of the workpiece material. So here we need to observe. So for example, number of hours which are the operations are required, number of hours. Such cases, so the machine time and the operator time is also very important. So whenever the machine is continuously operating, so such cases, so maximum heat can be carried out, maximum heat is generated. So during where the tool is interacting onto the surface of the workpiece. Such cases, so we can observe to carry the temperature. So from where the environment of the working place, so we can carry the temperature by application of the cooling media. That means, so many lubricants which are going to be used for carrying the temperature in the work spot. Work spot in the sense where the tool is interacting onto the surface of the workpiece. So these are the important parts and the line diagram of a lathe machine. See here once again. So this is the lathe machine. Headstock, tailstock, carriage or tool post, lead screw and bed and base. This is also called as the base, and a motor. So the motor is connected to the electricity, so which can convert the electrical energy into mechanical energy. Here the mechanical energy is nothing but the motion. What kind of motion? Circular motion. So it is connected by means of the belt drive. So there is a gap is observed between the where the motor is fixed. Always it is observed at the lowest part. So it is connected by means of the belt drive. The motion is transmitted. So from the shaft of the motor to the pulley of the headstock. So observe here. So this is the way the motion is transmitting. The motor motion is transmitting onto the pulley. Already the pulley is fixed in the headstock, so which can carry the motion, and here the check is going to be rotates. So as there are different gear system is also observed on the lathe machine. So for example, so as per the type of the metal, we want to follow the speed also. So as I already earlier I said that one. So that means, for example, if the mild steel is the workpiece, so we can operate with the highest speed. If the workpiece is the not that much of the stronger soft material like brass, bronze, copper, okay, and lead and aluminum, such cases is comes under the non-ferrous metals. So non-ferrous metals are the soft metals. So whenever we want to operate the soft metal as a workpiece, control is its speed. How it can be controlled in the sense, so as per the gear we can operate it. That means number of speeds, highest, lowest and medium. So as per that one we can operate the headstock here. So headstock is called as the live center, and this one is the tailstock. So tailstock is having a spindle, okay. So that spindle can be removed from the inside. The spindle is just like this one. This is the spindle. This is the spindle. So as the tip is exactly coincide to the center of the job. If it is the case of solid shaft, hollow shaft in the sense, we can remove this part, spindle part from the tailstock, and it is available as a hollow space, hollow area. So through that, if it is the case of the hollow shaft, so we can gone through. That means we can insert at the inside. So it is going to be moving. So as per the edge, as per the length of the workpiece, so we can set that one. So for example, if the bar length is, workpiece length is, for example, 10 centimeters, it cannot deviate from the position of the headstock. Such cases, it is not required the supporting. But whenever the length of the shaft is observed is more than, so whenever we can expect the deviation from its rotation, such cases definitely it should support from the tailstock. Such cases which we can observe the spindle at the inside. So tailstock, headstock, carriage and tool post. So on this tool post, so there are different types of the tool posts are there. So as per the type of the lathe machine, the tool post size and the shape can be changes. And the lead screw. So here I am going to share one of the important point for you. So the lead screw in the sense, so whenever we want to operate the external threads on the surface of the workpiece, so there the carriage is connected to the lead screw. That means we can check how much of the thread size is required. So that can be fixed in the carriage here. So here the handle is there or the fixing is there. We can change the position of the tool post. Okay. So tool as somewhat the inclination or the straight or upper direction or the lower direction. So that is going to be fixed at this condition here. Whenever it is connected to the lead screw, so as the lead screw movement as whatever we fix the thread pitch, so as per that one the lead screw can be rotates. So as per the movement of the lead screw, the carriage is moving, and as per the movement of the carriage, the tool is going to be interact onto the surface, that is coming backward and forward, backward and forward. So as per that one, the thread pitch is will be formed on the surface of the workpiece. So whenever we want to operate the external threads with the help of the lathe machine, so this is the one of the operation which is observed on the lathe machine. So the engagement of the carriage to the lead screw. So we will get the external threads on the surface of the workpiece. Okay, and this is the base, so which is having the robustic construction. Okay, so heavy size. Okay, and this is the first machine which the mechanical students are going to be interact in the workshop or maybe the production lab. So production technology lab or the manufacturing process lab. So the first machine, so that students have to have a demonstration is also required. So whenever we are very perfect about the demonstration, so whatever the feelings are there. So for example, if we are going to operate the lathe machine with uprightness, so the fixing of the tool or the fixing of the workpiece, if it is may not be perfect, so there are so many problems here which are going to be expected to the operator and as well as the student here also. Okay, so this is about the line sketch of the lathe machine, right? So what are the different types of the operations which are operates on the lathe machine? Let's see here. The first operation on the lathe machine is the step turning operation. Operations on the lathe machine. On the lathe machine. Number 1 is step turning. Step turning. Usually in old ancient days, who are going to be operate the lathe machine is called as the turner. Why the name implies as the turner? In the sense the workpiece is turns, rotates. That's what it is called as the turner. In biggest company in manufacturing, the biggest companies are who are going to operate the lathe machine is called as the turner. So why the name is implies in the sense the workpiece is turns, check is turns, headstock is turns. Okay, that's what is called as the turner. So step turning. Second one, taper turning. Taper turning. Next, facing. Facing. Number 4, thread cutting. Thread cutting. Number 5, knurling. Knurling. Number 6, drilling. Drilling. Number 7, reaming. So these are the operations which are carried out on the lathe machine. So coming to here, what is step turning? Step turning in the sense, whereas in the workpiece there are different diameters are simultaneously observed, it is called as the step turning. That means, for example, 10 mm, next 15 mm, next 20 mm. So the first step is the 10 mm having length, next 15 mm having length, next 20 mm having length. So these kind of the operation is called as the step turning operation. I will show the diagram also. See this one. This is the step turning operation. So capital D, small d1, small d2. There are different diameters with frequent lengths. It is called as the step turning operation. Next, taper turning operation. So taper turning in the sense, one side having the higher diameter, other side is having the lower diameter. Okay, so there is the calculation is also there, taper turning calculation, that is alpha, capital D minus small d by L, you will get the theta. So here alpha is equal to capital D minus small d by length, you will get the taper turning angle. So, taper turning angle in the sense it is not manually operated. Once we can fix the angle, then automatically, so whatever the angle that you want, whatever the diameter that you are going to be get, higher and the lower, it is automatically operated by means of the carriage and the tool post. So, for that case we need to calculate the angle. So, for angle calculation here we are using the capital D minus small d by length. So, what is this capital D? What is this small d? What about that length? See this one. For example, here this is the taper, this one is the taper I want. That means I need to prepare a job on step turning. After the step turning, after the facing operation, I want to make the taper turning operation. This is the capital diameter, this one is the capital D, this one is the small d, a length of the taper is L. Okay. So, by using of this one capital D, small d and L, I will get the alpha. 2 alpha, that means upper and as well as the lower, 2 alpha. So, that I will get the alpha angle, and as per that one I can set the tool post. So, whatever the angle that I got, so as per the calculation I need to set the tool post about that inclination, then automatically it is connected and operation is carried out. So, that operation is called as the taper turning operation. Next one is facing operation. The starting operation on the lathe machine is the facing operation. What is facing operation? So, because the surface, the starting surface of the end of the shaft or the end of the workpiece is not even, not in the even. So, we can make the surface is smoother and straight away. That operation is called as the facing operation. So, what is facing operation? See this one. Here this is the face, this one is the face. So, here during the manufacturing process, so the labor, the helper may cut the number of workpieces. All this number of workpieces are at the edges. If please observe at the edge, the face is totally it is uneven. To remove that uneven portion, the first operation which is observed on the lathe machine is called as the facing operation. So, that is the facing operation. Next one is thread cutting operation. Earlier I told how the thread cutting process is carried out on the lathe machine. That means whenever the carriage is engages onto the lead screw, then automatically this operation is going to be takes place. So, that operation is called as the thread cutting. So, thread cutting in the sense for screwing purpose, for unscrewing purpose, the threads which are observed on the tool workpiece. So, that operation is nothing but the thread cutting operation. Next one is knurling operation. So, here usually where the handles are there, whenever a component is having a handle, that handle should observe as the very rough surface. So, that is not that is not automatically getting. So, it is one of the operation which is observed on the lathe machine with the help of a tool. That tool here it is called as the knurling operation or the diamond cutting operation. The second name for the knurling operation is called as the diamond cutting operation. That means, so after the operation is over, all the operations are over. So, where we want to hold the workpiece. So, on that one, so if it is observed as the smoother surface, it may be the slippy or it may be slips when we want to grip or when we want to hold the workpiece. So, from the area, so it should be observed as the rough surface. So, to create that rough surface with help of the tool is called as the knurling tool, or that kind of the operation is called as the knurling operation. See here, this one is the knurling operation. See here, this is, I will show the different operations here. Step turning operation, facing operation and taper operation, and finally on here I am going to do the knurling operation. So, where I hold the workpiece, so it should not slip away from the holding part. That is what here I am going to use the knurling. So, it is nothing but the diamond cutting. So, this is the knurling operation. Knurling operation. Step turning operation. This one is the taper operation, taper turning. This one is the facing operation. At a time I shown the different operations on a single component. Okay, so that is a knurling operation to hold the surface. The surface should observe without slippy. Okay, so that we can use one of the operation. That operation is called as the knurling operation with the knurling tool. With the knurling tool. Okay, so next one, drilling operation. So drilling operation means actually the drill bit is not so far fixed on the tool post. So one accommodation is there. That means where the tailstock is there. Usually the tailstock, the purpose of the tailstock is to support the length of the jobs which are operates by using of the lathe machine. So one more use is also there with the help of the tailstock. So we can fix the drill bit where the accommodation in the tailstock. So already we know the twisted drill bits which are used to make the holes in the metal parts or the material surface. So we can fix the drill bit at the end of that means where the end is nothing but it is nothing but the dead center. In the dead center we can fix the drill bit. So the drill bit is going to be moving and against it can be forced. So where we want to make the hole. So that operation is nothing but the drilling operation with help of the lathe machine. Usually all the drilling operations are performed on the drilling machine only, not on the lathe machine. But the lathe machine can accommodate the drilling operation also. So what is the drilling? So drilling means we can make the holes with the help of the drill bit. It is nothing but the drilling operation which may perform on the lathe machine. Next, what is the reaming operation? Reaming operation means clean the already drilled hole. So this operation is also performed on the lathe machine. This operation is also performed on the drilling machine especially. Okay. So here what the information is required? The lathe machine is also possible to make the holes in the material, that means in the workpiece. So with the help of the drilling machine we can make the holes, not only with the help of the drilling machine. So these are the operations are carried out on the lathe machines here. So let it come to here. What I explained here, this lathe machine is the traditional lathe machine. So traditional lathe machine in the sense operator is required. There is no program is required, not required here. The program is not required here. So entirely we can specify the dimensions on a model, on a chart. So as per that one we can operate the number of tools with the number of operations. So we can finalize the object here. So this is total, it is called as the manually operated lathe machine. Manually operated lathe machine. Next, numerical control lathe machine is also there. Numerical control, it is called as the NC lathe machine. NC, numerical control lathe machine. Next, CNC lathe machine. CNC lathe machine. So the presently all the manufacturing systems are converted into, not 100%, converted into traditional to conventional. So conventional in the sense it is easy to be operated because the more accuracy is required and mostly time has to be saved. Okay, operator time and as well as the machine time should be saved from the operation, number of operations. So it is observed in the traditional machining, there is a lot of time waste is observed, operator timing and as well as the machine timing. So that we can convert all the traditional machines into the conventional machines. That means, so presently in the mechanical field all the manufacturing industries are following are using the conventional mode of machinings only. That means, so all the machines are operated with computer. That means it is already programmed, the program is already fed into the system. The system can control, the computer can control the number of machines at a time. Okay, so for example, if similar number of products that we want to manufacture at a time. So for example, the type of bolt, the type of nut, huge quantity of the order is there from the customer itself. So if it is the case of the traditional method, it can take plenty of time. But when we want to operate with the CNC machining or the CNC operations or the CNC methodology, so the number of production, that means whatever the huge number of orders, we can accommodate with less time, we can finish with less time. So that's what all the manufacturing industries are presently following, only the conventional mode of machining, that is only the CNC lathe machine, CNC milling machine. All the machines are operating with only computer numerical control machines, and the manufacturing system is totally changed here. So what are the changes which are observed in the sense, it is totally automatic operation, it is called as the automation. So automation in the sense, so for example, if the order is good number is there, maximum number is there, thousands of the customer is asking a component, or for example car manufacturing industry, automobile industry, all these are the multiple type of the objects, or the multiple number of objects are having similar size, similar shape, that is called as the mass production, large scale production. So the large scale production should be satisfied not with the traditional methodology or the traditional machining. So definitely we want to approach only the automation only. So with the help of the automation, we can satisfy the customer. The customer means not a single customer, huge number of customers. So here the production is not for the local, it is for the national and international also. Our product may be reaches to the outside countries. So it is nothing but the multinational production or the huge number of mass production. Such cases, the traditional methodology is not so far it is suitable. So we can approach only the new automation with how it is possible with CNC lathe machines only, or the CNC machining only. All the machines are accommodated with only CNC operation, computer numerical control machines only. Then it is possible to compensate. So whatever the orders are there, or whatever the companies which can give the order, we can satisfy the customer, and as well as so what we expect the super finish or the surface finish or the tolerances, accuracy, all these are possible with the help of the automation only. Right. Next one, what are the different types of the lathe machines are there? There are 3 types of lathe machines in traditional methodology. That means, for example, this is the engine lathe. What I explained about the skeleton diagram is belongs to the engine lathe. The first lathe is the engine lathe. Number 1 is the engine lathe. Next one, capstan lathe. Next one, turret lathe. Both are called as the same, turret lathe. Okay, and the fourth one is the CNC lathe machine, NC. D, fourth classification is the NC machines, numerical control lathe machine. Next, E is CNC lathe machine. CNC lathe machine. Engine lathe, this is the oldest lathe machine. Usually it is operating with the steam engine, where the power generation is not observed. It is the oldest and ancient lathe machine, engine lathe machine. Next, capstan and turret. What is a turret? So usually the tool post is a square shaped and it is operating with a lever. See this one. This is a tool post. So here a lever is there. So this lever can be operate clockwise direction and anti-clockwise direction, where we can fix, we can accommodate the tool where this gap is observed. This is the gap. There we can fix the tool. In ordinary lathe machines, so it can accommodate only the 4 tools at a time. So 4 tools in the sense 1, 2, 3 and 4. So 4 tools at a time. Whatever the tool that you want. Here the tool is nothing but it is a single point cutting tool. But in the single point cutting tool, there are different single point cutting tools are there. So as per the type of the operation, we can change the single point cutting tool. So for example, facing operation, one kind of the single point cutting tool. Turning operation, another kind of the single point cutting tool. Thread cutting, another kind of the single point cutting tool. All these are the only single point cutting tools, but about its rake angle, the tool can be varies. So for example, the facing operation, we can change the tool. At a time, the 4 tools we can accommodate on this simple type of the tool post. So this tool post is observed only in the engine lathe machines and the capstan lathe machines. In turret, the tool post is too differ. See here, this is the turret. It is having a hexagonal shape. See here, how many faces? Totally 6 faces. So 1, 2, 3, 4, 5 and 6 faces. So in this 6 faces, we can fix the 6 tools, which is plus 2 more than the ordinary type of the tool post. In ordinary tool post, it can accommodate only the 4 tools at a time. But in turret lathe machine, it can accommodate the 6 tools at a time. 6 tools. Single point cutting tool, reaming tool, drilling tool. Okay, so whatever you want, whatever the operation that simultaneously, it is in sequence order, in series order. So we can change the position of the turret, and the tool is going to be interact onto the surface of the workpiece here. This is called as a turret. So as for this one, the lathe machine is called as the turret lathe machine. So engine lathe machine, capstan turret lathe machine, NC machine and CNC machine. So I will share few of the information. What is that? What are the changes which are observed between the traditional and as well as the convention? So why the production rate is so far increased in the CNC lathe machine? So this point is very important. So whenever we want to change the tool, the operator timing is consumes maximum in traditional method. But whereas the case of the CNC lathe machine, the tools are automatically changed as per the program. Whatever the program which is fed into the computer, so as per that one, the computer will give the instructions to the tool post. Automatically the tool changes its position, and whatever the operation is required, so as per that one, the tool is going to be interact onto the workpiece, so that the production rate is increases. This is one of the example. So why the production rate is increases with the help of the CNC machines, in the sense automatic operations, total it is automated. The workpiece setting, workpiece changing, okay, tool changing, tool movement, speed, feed. So everything which are going to be operated with the help of the computer. That's what the production rate is huge, abnormally changes are observed between the traditional method and as well as the CNC technology. Okay, so these are the two differences that we need to observe in the traditional methods in only ordinary engine lathe machine and as well as the turret lathe machine. So engine lathe machine, capstan lathe machine, okay, and the turret lathe machine. So here the changes are observed only the number of tools which are operating in traditionally. That means there are 4 tools which are accommodated on the ordinary lathe machine, that is the engine lathe machine, whereas the case of the turret, there are 6 tools we can accommodate at a time. So that the tool changing, actually this is the method time taking process, but as we are going to compare the engine lathe and the turret lathe is the best one. As we are going to compare the turret lathe and the NC is the best one. As we are going to compare the NC and CNC is the obviously the best one. So because it is totally controlling, changing number of speeds, material removal rate, everything is observed in the program itself, whatever the program which is fed into the system. So as per that one, as per the instructions of the computer, all the changes are observed. So that is about the information regarding the lathe machine. And next one, what are the metals, what is the materials which are used to manufacture the each and every part in the lathe machine. So come to here. So headstock, it is totally manufactured with mild steel, because it is the toughest one, hardest one. The base is manufactured with the help of the casting process, because it has to carry the maximum load. What is the load here? It has to carry the bed, it has to carry the headstock, tailstock and carriage. So all these parts are accommodating on the guide vanes of the bed. The bed is fixed on the base. The base is fixed on the earth. So whole load is carried on the bed itself. That's what the bed and as well as the base is manufactured with the casting process. It is the selection criteria of the process is the casting process to manufacture the base and as well as the bed. Okay, and the tailstock, same headstock material. Carriage is steel. The carriage, that means the bed is the steel, the carriage is also the steel. So because when you want to watch so almost it is totally lubricating. So why it is going to be lubricating? In the sense, the movement is very easy. So while the movement of the carriage from left to right or backward to forward or up and down, all these are possible. It is to be lubricated because the surface finish should be very highly accuracy. So this is about the parts which are used with the different materials. And the next one, what are the tool materials? So almost the HSS tool, okay, high speed steel tool material which is used to manufacture all the types of the single pointed cutting tool. All the single point cutting tools are manufactured with HSS steel, high speed steel. High speed steel. High speed steel. All the single point cutting tools. So I will show the nomenclature of the single point cutting tool also. You can see here. This is the nomenclature of the single point cutting tool. Single point cutting tool. Single point cutting tool. So this is the leading edge. Leading edge, shank, holding, a relief angle, end relief angle, end relief angle. This is the face. Top face, and it is the bottom face. So here, as per the cast of the tool, so here where the tool is interacting, here is the tool is interacting here. Where the tool is interacting onto the surface, it should observe as the hardest one. And here it is only where we can accommodate the tool, on the tool post. So here that area, that space, that material is not interacting the workpiece, so that it is not observed as not that much of the stronger. That's what it is, combination of the different tools. So for example, this cutting edge is observed as to design with, to manufacture with HSS steel. it is observed as the normal, that means mild steel. There is nothing to worry because it may not interact onto the surface. But sometimes, so what are the working force which are getting onto the where the shank is there, sometimes it should be observed as very strongest one. So this is about the single point cutting tool. Single point cutting tool. Single point cutting tool. There is the calculation is also there, that means here, so sometimes we need to calculate the material removal rate and the speed and feed, all this terminology which is observed in the lathe machine. MRR, material removal rate, and speed and feed. So feed in the sense the tool is interacting onto the surface of the workpiece. How the speed of the workpiece is rotates. Material removal rate is depends upon these two factors, speed and as well as the feed. So there is a calculation part is also there on the lathe machine. So for 1 hour, how much of the material removal rate is there, as which is depends upon the tool position, tool movement and speed of the workpiece, and the operator skill is also. So we can observe the cases here. So material removal rate and speed and feed, all this terminology which is observed in the calculation part. So this is about the brief introduction about the lathe machine types, and the different lathe machines, and what are the operations, and what are the tools which are used on the lathe machines. So thank you very much once again.